Okay, and we should be up. Let me just check. All good. Why again my screen is not displaying. So let me just do that. Okay, cool. Yeah, everything's up. Okay, cool. So let's get on with it then. So last time we did last time we were doing L values, and remember that L values are something that evaluates to an object, um, like a function or a variable, whereas a R value evaluates to a value, like for example x plus 1. Then we did L value references, where the return type or the reference type, such as an integer, boolean, whatever, would be you would use an ampersand, and that would reference to, for example, x here. So it references to that. And now we're doing. We learnt about modifiable and non-modifiable, i.e., variable and const expression. And now we're doing L value references to const. So this is a non-modifiable const value, and this will produce an error. So we know that this is invalid. We know that this is invalid code. So we got int main const int x assignment of 5. This is non-modifiable. Then we have a int return type, or and we're referencing it, and then it's going to be x. And it's going to produce an error because you cannot bind a non-modifiable L value. Okay. And then as always, in our main function, we'll return 0. So it is possible to reference to get a reference for a const value. So L value. Oh, this is exactly the same. Okay. So by using const keyword when declaring a L value, remember L value is left value, we tell an L value reference to treat the object it is referencing as a const. So um, this is okay. So we got int main. Let me just write that myself. So we got the preprocessor of include, we got the input output stream header, we got a return type of integer main, we got const int x5, this is non-modifiable. Then we have const int reference of ref, and we're referring to x. This is okay as the ref is an L value reference to a const value. Okay, that makes sense. So then we can simply do our standard character output ref, and then as always return 0. So this should therefore print 5. And it does. Cool. Nice. No. All right. Because L value references to const treat the object so this is okay as we are referencing and accessing the const object, whereas this is not okay. This is not okay as we cannot modify an object through a const reference. As you can see here, expression must be modifiable. Okay. So, initializing L value reference to a const modifiable value. Initializing an L reference to const with a modifiable reference. So L value references to const can also bind. So L value references to const can also bind to modifiable L values. In such a case, the object being referenced, so in this case, the object being referenced is treated as a const when accessed through the reference, even though the underlying object is a non-const. So, for example, int x5, this is modifiable. This is modifiable. Const int reference ref to x. This is a const ref to a modifiable L value. Then we have a standard character output of ref with a line break. Then we have ref equals 6, which will produce an error. But if we did x equals 6, this is okay because it's modifiable. And for example, if we did this, this would print 6 and this would print 5. So this would print 65. It's not going to run, is it? So let me just comment that out. And there we go. We get 66. No, because no, that does make sense because ref is a reference to is an alias for x. So this would print 66. So if we did that, that would make more sense. Okay. So the best practice is to favor L value references to const over L value references to non-const unless you need to modify the object being referenced. So initializing an L value reference to a const with an R value. Okay. So L value references to a const can also bind to R values, such as this. When this happens, it temporarily. So initializing an L value reference to a const with a value of a different type. Initializing an L value reference to a const with a value of different type. He means like a return type. L value references to a const can even bind to a different type so long as the values are implicitly converted. Remember, we've done that before. So here we have a const double reference of R1, temporary double initialize with value of 5. Then this prints 5. Then we have a character of C initialized as A, and we're referencing R2 to C. Yeah, that makes sense. Because 5 is an integer, and remember it can be converted or promoted to a double. And C, whilst it's a character, it is converted via the ASCII to an integer, which is then converted to which is then converted to an integer. Const references bound to temporary objects extend the lifetime. Okay, so not that much. Const references bound to temporary objects extend the lifetime of the temporary object. So temporary objects are normally destroyed at the end of the expression they're created. Yes. Given the statement const int reference ref 5 Consider what would happen instead if the temporary object created to hold value 5 was destroyed at the end of the expression that initializes ref. Reference ref would be left dangling, and this would cause undefined behavior. Yeah, to avoid dangling references in such a case, C++ has a special rule. When a const value reference is directly bound to a temporary object. When a const value reference is bound to a temporary object, the lifetime of the temporary object is extended to match the lifetime of the reference. Okay. So the temporary object holding the value 5 has a lifetime of ref. Therefore, we can use it here. Yeah, just like a normal object. That makes sense. In the above example, when ref is initialized with the value r value of 5, a temporary object is created and ref is bound to the temporary object. The lifetime of the temporary object matches the lifetime of ref. Thus, we can safely print the value of ref in the next statement. Both ref and the temporary object go out of scope and are destroyed. Yeah. So const reference expression values, const expression L values. When applied to a reference, const expression allows the reference to be used in a constant expression. Constant expression references have particular limitation. They can only be bound to objects with static duration, either global or local. This is because the compiler knows where static objects will be instantiated in memory, so we can treat the address as a compile time constant, like we've learned previously before with constant expressions. A constant expression reference cannot bind to a non-static local variable. This is because the address of the local variables is not known until the function that they are in is called. Because remember that constant expressions are evaluated at compile time. Yeah, that makes sense. Hang on a sec. Okay. So here we got a global variable of gx5, and we're using maybe unused constant expression int reference ref1 to the global variable. So it can bind to the global variable. Then we have a static int of 6, and then we're referencing to it here in ref2. But then we have a non-static and a non-global, and we're referencing reference 3 to that because it's a non-static object. Okay, I want to do this myself just to practice because I'm a little bit iffy on my const expression variables. So what I'm going to do is we go here, we can use the include preprocessor, then we create the global variable of int global x5. This creates the global variable. Then we have an int of main, and then we're using maybe unused, and we have a const expression of int with a reference ref1, and we're referring to gx, the global variable. This is okay as a const expression can bind to an object with static duration, aka either a global or static local. So then we create a static local int of s static x. This creates a static local. Then again we use maybe unused, and we do a constant expression of ref2, and we refer to sx. This is okay as a const expression can bind to an object that is either global, that has static duration, that can bind to an object that has static duration, that has static duration, i.e. either a global variable or a static local variable. So then this would not be okay. This creates a non-static local variable, and then again maybe unused, and then we're doing const expression of int reference ref3, and we're referring to this. This is not okay because x is a non-static local variable, and a const expression reference can only be bound to a object with static duration, aka either a global variable or a static local variable. Okay, and we should get an error. Yeah, show errors. Ref3 must be initialized by a global constant variable. Yeah, cool. Okay, so when defining a constant expression reference to a constant variable, we need to apply when defining a constant expression reference, to a constant variable, we need to apply both constant expression, which applies to the reference, and constant expression, which applies, and const, which applies to the type being referenced. So the constant expression is the reference, and the const is the referent. So again, I want to do that myself. Include preprocessor, input output stream. We have an integer main function. Then we have a static, i.e. a object with a static duration. Static const int x, and then 6. This is a const int and is the referent. Then we have a const expression, and then a const int ref of and then sx. So in this expression, the const expression is the reference, and the const is the referent, aka okay. And then we do return 0 as always. And that compiles fine. So given these invitations, constant expression references are not typically used much. But I think it's still good to know. Okay, pass by L value reference. All right. Okay, in the previous lessons we did L value references, L value to const. Why create an alias to a variable when you can just use the variable itself? True. In this lesson we'll provide some insight into what makes the references useful. And starting, you'll see later in this chapter, you'll see why. Where an argument passed to a function is copied in the function parameter. So we got a void function, print value with a parameter of int y. We then print y. Then we create in our main int x, and we print in x. Yeah. This means when we call the function, we made a copy of our argument only to use it briefly and then destroy it. Fortunately, because fundamental types are cheap, isn't a problem. Most types provided by the standard library are class types. Class types are typically expensive to copy. Whenever possible, we want to avoid making unnecessary copies of objects, because remember, a standard string is the owner, whereas a standard string view is a viewer, and a owner is a lot more expensive than a viewer. So we got include input output stream, include string header, void print standard string y. Y is destroyed after printing here. Then we have a standard string of x hello world. X is a standard string, and x is passed by value copied. Surely then you could just use a standard string view. While this program is also inefficient, identical to the prior example when print value. So pass by reference. So I am going to one way to avoid expensive copy calling a function is to use pass by reference instead of pass by value. When using pass by reference, we declare a function parameter as a reference type. When using a pass by reference, we declare a function parameter as a reference type. Okay, or a const reference type, rather than a normal type. So when using a pass by reference, we declare a function param as a reference type or const reference type rather than a normal type. When the function is called, each reference parameter is bound to the appropriate argument when we call the function. Because the reference acts as an alias for the argument, no copy of the argument is made, therefore making it not very expensive, right? So here's an example. So I want to, so we got the preprocessor of include, we got input output stream, we got the preprocessor of include string. Then we have our void print value, and we have a standard string reference of y. And we simply print y here. So y is destroyed here. Then in our integer main function, we do standard string x, and we initialize it with hello world. Then we call print value x. So x is now passed by reference into the reference param of y. This is in I assume it's inexpensive because we are essentially viewing rather than owning it. Why is that wrong? Why is that causing me errors? Is it just a... What am I doing wrong here? Show errors. That's fine, because I was closing my function early. So we run it. Cool, we get hello world. Okay, reading that does make sense. Because it's relatively inexpensive, This is because our original param in print value has now been changed to an L value. We know that an L value evaluates to a object, aka a function or variable, whereas before it was essentially an R value which evaluates to a value. Okay, I just need to charge my laptop. Okay, cool. Okay, that's starting to make sense now. So by using that, okay. And it's all because of this, the ampersand. Whereas before, we had to create a new string each time. Okay. So, pass by reference allows us to pass arguments to a function. So essentially, it's like you're able to use creating the std standard string, which is like an R value. No, hang on. Yeah, so standard string would be an R value, but by using the ampersand for a reference, it then turns into a L value. So pass by reference pass by reference allows us to pass arguments. And remember, the difference between a parameter and an argument is a parameter is when you're creating the function or defining it. An argument is when you're calling it in wherever you're calling it. Argument to a function without making copies of those arguments each time the function is called. The following program demonstrates that a value parameter is a separate object from the argument, while a reference parameter is treated as if it were an argument. So we have a sec. Yeah, cool. So we have a void print address. So this value parameter, no. Yeah, this value parameter is treated as separate, whereas this reference is treated as if it were the argument. Okay, so if using a value param, aka a non-reference param, the parameter is treated as a separate object from the argument. Whereas a reference argument of, for example, int ref is treated as though it is the argument itself. Okay, I just want to do that myself. So we've got include input output stream. Then we got a void print address. Then we have int val, and we have int reference ref. And we're going to be printing standard character output, the address of the value parameter, which is treated as a separate, which is why it's expensive, because it creates it again and again and again every time you call the function. Value param is val. And then I'll just do a line break here. Oh, you're doing it. You're referencing that. Then we have a standard character output, the address of the value of the reference param is, and we reference ref, and then we do a line break. Then in our integer return main function, we do int x of 5. We do a standard character output of the address of x is double D, and we're referencing x. And then we print address x for the val and x for the ref. And then as always, we return 0. Okay, so then, okay, so by using this, that means we actually will get the reference, the address. So let me clear my terminal. So these are just reference points. Oh, these are the address of each one. The address, so the address of x, aka 5, is this. And the address of the value param is this. And the address of the reference param is exactly the same as your address, because it's treated as the argument. Okay. So so the address of X, which is here, um, is this. So because we need to pass, that makes more sense now because the int ref is treated as if it were the argument, which means you don't need to create a new one. Whereas the int val is treated as separate, which means you need to create a new address for it. Okay. This produces this output. So this proves that um, the that a reference param is treated as though it were the argument, as it has the exact same address as our int x5, and the address of the non-int of the non-reference, the standard object of the value param is different, as we need to create a new address for it rather than just simply referencing it like with int ref. Okay, I'm just going to take a quick break here. And I'll be back to continue. With pass by reference allows us to change the value of an argument. Okay, right, be right back. siamo? Hello? Yeah. All good. Yeah. Okay, cool. So okay. All right, let's continue then. Turn that down. And turn that down as well. Okay. So pass by reference allows us to change the value of an argument. When an object is passed by value, aka non-reference, and which means when we create the parameter, or rather the argument, it creates a new copy which is expensive. Whereas if we use reference, then it's a lot less expensive because it's treated as if it were the argument. Okay. This When an object is passed by a value, the function parameter receives a copy of the argument. This means that any changes to the value of parameter are made to the copy of the argument, not the argument itself. When an object is passed by a value, the function parameter receives a copy of the argument. Yeah. This means that any changes to the value of the parameter are made to the copy of the argument. So the copy of the argument, not the argument itself. So include inbound output stream, void add 1. Sorry, yeah, when it's passed by value. Yeah, no, that makes sense. I don't want to copy this, I want to copy the reference rather. The reference one. This modifies the copy of x, not the actual object. So when you do x initialized as 5, you then print that, you then add 1. X has not actually been modified because x, which is essentially y, dies here. And so this does not actually get added. So this prints 5 and 5. Okay. Because y is a copy of x, when we increment y, it only affects y. Yeah. However, since I reference x identically to the object being referenced, when we pass by reference, any changes to the reference will affect the argument. So now this is the one I want to do. So you got int reference y, which means now that y is bound to the actual object of x that we pass in the argument. This will actually modify the object of x. So in our int main function, we have int x of 5. Then we have a standard character output, and we're printing and we're calling add1 for x, which is, as you can see here, referencing to y. So we will then actually get this, i.e. the increment. Then we're printing standard character output value x with a line break. And then as always, we're returning 0. So x has now been modified as we have used pass by reference, and the reference param in add1 is treated as though it is part of the argument. So we should therefore get 5 in here. Then we're going back to add1 and we're passing in the increment, and we should now get 6 because x has now changed. So we print that, and there we go. We get value 5, value 6. I just want to add something to this. That should actually be single. I want to add no, because it'd be the same address. No, the address of this, the address of int x5 is, and then what do I want to do? I want to do another exertion operator, and then I want to do x, and then I want to do exactly the same here. The address of this x is, and then that will show me the address, right? Yeah. Just make it a little bit more clearer. So you can see here that they have exactly the same address. Yeah, I believe that's hexadecimal. They have the exact same address, whereas I assume in the other one we wouldn't have the same address. Okay, good to know. So I just want to copy that. First of all, I want to copy this one. Then I want to copy this one. And then this prints. And that just proves that even though we have a different value, we are referencing the exact same thing because of our reference parameter here. Cool. That makes sense to me. All right, next. Where's my mouse? So it's bound to the argument x. The argument x, when add1 function increases, it's actually increasing x, not a copy of x. Okay. Passing values by reference to a non-const allows us to write functions that modify the value passed in. Yes, that makes sense. The ability for functions to modify values passed in can be useful. So, pass by reference can only accept modifiable L values. Because a reference is a non-const value, because a reference to a non-const value can only bind to a modifiable L value, this means that the pass by reference only works with arguments that are modifiable L values. Yeah, that makes sense. In practical terms, this significantly limits the usefulness of reference to non-const, as it means we cannot pass const variables or literals. So we have a void print value, we have an integer reference of y, which accepts modifiable values, and then we're printing y. Then in our main function, we're creating a local variable. We're creating a local variable or a local object of integer x5, printing x, so we're banding x to y. We're then creating constant integer z and initializing it with 5. And because our parameter is non-modifiable, this is not possible. Then we print 5 but we get an error because 5 is an R value. So fortunately there's pass by when we take. Okay, so the next one is pass by const L value, whereas this was pass by L value reference, i.e. modifiable. Now we're going to do non-modifiable. Okay, so next is, yeah. So now we're going to do pass by const L value reference. Hey, shout out Alex, by the way, whoever he is, for this, because this is really helpful. So unlike a reference to a non-const, let me write this down. Clear this and create more space. So unlike a reference to a non-const, which can only bind to modifiable values, a reference to const can bind to modifiable values, non-modifiable values, and R values. Therefore, we can make a reference parameter const, then it will be able to bind to any type of argument. Okay. So I think it's probably best to do it ourselves. So we got the preprocessor, we got the preprocessor include of input output stream as always. We have a void function of print ref, and we're making a const int reference to y. So y is a const reference. Then we are simply printing that. So then in our integer return main function, we're going to make int x be equal to 5, which is a modifiable value. Then we're going to be doing print ref of x. This is okay as x is a modifiable value. Y, aka this, the y param binds to x. Then if we do a const int z5 and we print z, this is okay as the y param is a const, and so is z. therefore y binds to z. Then we print 5. This is okay as 5 is a R value literal. Y binds to the literal of 5. Print ref. So we should then, after returning our function, get 555. 555. Nice. Okay. Passing by const offers the same promo benefits as non-const, whilst also guaranteeing our function cannot change the value being referenced. For example, this is disallowed because ref is a const. Then I want to copy this. Yeah. So the best practice is to favor passing by const reference over passing by non-const reference unless you have a specific reason to do otherwise, e.g. the function needs to change the value of the argument. Now we can understand the motivation for allowing const L values references to bind to R values. Without that capability, there would be no way to pass literals or any other values to functions that use pass by reference. And remember, it is, if you want to have your code be inexpensive and efficient, it is best to use reference in your parameters rather than value types. Okay, passing arguments of a different type to a const L value reference. Okay, quite a bit. No thanks. So, I'm actually going to take a quick break here and I'll be back in a minute. Oops. Okay. Uh, still fine? Hello? Yeah. Okay. Right. Next up is passing arguments of a different type to a const L value reference parameter. So we noted that a const L value reference can bind to different types as long as the value is convertible to a type of that reference. This conversion creates a temporary object that the reference parameter can bind to. The primary motivation for allowing us to do that for this is that we can pass a value as an argument. Primary motivation for allowing this is so that we can pass a value as an argument. To either a value parameter or a const reference parameter easily the same way. So I want to do this myself. Then we have a void parameter return type of print val, and we have double D, and then we're printing out D with a line break. Then we have another void parameter of print ref, which is going to be a const double reference D, and we're going to be printing D here. Then in our return function, we're going to be doing print val, and we're going to be doing print ref. 5 converted to a temporary double, copied to parameter D. Because this has a value this has a value param it creates a copy to param D, whereas because this has a reference param, this temporary double is bound to param D. And then if we run it, well, it's still 5 and 5. But that does make sense because the difference between a value and a reference parameter is the value creates a copy, which means it's expensive, whereas a parameter creates whereas a reference creates a binding. Okay, that does actually make sense. Nice. So, with pass by value, we expect the copies to be made. Yes. With pass by reference, each type of the argument matches the type of the reference, or it will result or ensure that the type of the argument matches the reference, or it will result in an unexpected conversion. So, I don't think we'll finish this today, but we'll see. Mixing pass by value and pass by reference. So we got a pass by value, we got a pass by reference, and we got another pass by reference here. Const reference. Yeah, I don't think I need to write this out. I will just copy this section here. When to use pass by value versus pass by reference. So we have pass by value, pass by reference, and pass by const value. When to use it. So, is a general rule of thumb. Fundamental types and enumerated types are cheap to copy. So they are typically passed by value. Class types can be expensive to copy, so they are typically so as a rule of thumb, pass fundamental types as class types. Pass fundamental types by value and class types by const reference. If you aren't sure what to do, pass a const reference as you'll likely encounter unexpected behavior. So the best practice is so here is a list of when to use what. So pass by value, enum types, like we said here, views, spans, references. We haven't done these. And then pass by reference. Arguments that need to be modified by the function, types that aren't copyable, types where copying ownership implication we want to avoid, and types of virtual functions inherited from that are likely to be inherited from. Hopefully it will become like normal, um, clearer, come on, clearer over time as we progress. I'm going to leave advanced for now. Let's move on. Yeah, we haven't done structs yet. So I'm gonna move on from this. And I'm gonna do this now. Okay, cool. For function parameters, prefer standard string view over const standard string and. Because remember, we learned earlier that standard string view is basically a viewership rather than owner. Okay, one question that keeps coming up when writing, should it be standard string reference or a const standard string reference or a standard string view? In most cases, standard string view is the better choice, as it can handle a wider range. A standard string view also allows the caller to pass a substring without copying that substring its own first. Okay, so we have avoid do something with a const reference standard string, and then we have a void of do something, but this time we just have a standard string view. Prefer this in cases. There are a few cases where const reference standard string view are more appropriate. If you're using an older version, string view isn't available. If your function needs to call some other function that takes a C style string or a standard string parameter, then the constant reference may be a better choice, as standard string view is not guaranteed to be non-terminated. So the best practice is to prefer passing strings using standard string view by value rather than const standard string by const reference, unless your function calls other functions that require C style strings or string params. Okay, even though it says advanced, because we've covered standard string view and standard string in previous streams, I feel I want to cover this. And the worst thing that can happen is that I learn something. So we'll do here, and we'll do here. So, as a reminder, the type of the argument, if the type of the argument does not match the type of the corresponding parameter, the compiler will try to implicitly convert the argument to match the type of the parameter. Converting a value creates a temporary object, like we learned with the int and the double. Creating a standard string view is inexpensive because it's a viewer, as does not make a copy, it's viewing, exactly. Creating a copy of standard string is expensive because you are the owner and you're making a copy rather than viewing a copy. Just a little bit of space, just so I can see better when coming back to this. And then there, there. Cool. So with a standard string view value parameter, if we pass in a standard string argument, the compiler, as we learned previously, the compiler will convert the standard string, and by previously I mean other way back in other streams, string to a standard string view, which is inexpensive. If we pass in a standard string view argument, the compiler will copy the argument into the parameter, which is inexpensive. if we pass in a C style, because remember, standard string view can convert a standard string view and a C style string. Yeah, and all of the above is relatively inexpensive. Okay. Whereas with a const standard string reference, if we pass in a standard string, the param will reference, the parameter will reference bind to the argument. This is inexpensive. If we pass in a standard string view argument, the compiler will do an implicit conversion and produce a compilation error. We can then use static cast to convert it X. But this is expensive because it will make a copy. Yeah, but then the parameter, that the reference parameter, will then bind to that, but we've already created a copy again, which means it's expensive. So it's better then to use a standard string view. So it is better than to use a standard string view for your a value param rather than a const reference const standard string Thus, a const only handles inexpensive. So in the same code, the same encode form. So we have a void, we have it preprocesses of include as normal. We have our input output stream, we have string header, and we have string view header. Then we're creating a print standard view function. Which is standard character output string view, yeah? And then here we're creating, so this is a value parameter, and then we have print string with a const reference of s. Then in our main function, we are creating a string view. We're creating a string of hello world, and then we're creating a view of s. So we pass in standard string view parameter. This is inexpensive because we're viewing s, and obviously it's being, but s is this, which is being bound to this, and then here sv is an inexpensive copy of this again. Oh, sorry, this again. And then here we're converting a C style literal string to a string view, which is fine. Now we're passing in our const reference, and we're just doing s, which is fine because it's a string argument, so no conversion is needed. Then we have a string view, which is produce a compile error. So we need to use static string, static cast, the type we want to convert it to, and the expression. Then we have a C style string literal, which is very expensive. And because it's a different type, it will create a temporary object. Okay. Additionally, we need to consider the cost of accessing the parameter inside the function. Because standard string view parameter is a normal object, the string view being viewed can be accessed directly. Accessing standard string view reference parameter requires an additional step to get the reference object before the string can be accessed. Finally, if we want to pass in a substring of the existing string, it is comparatively cheap to use standard string view substring. Whereas in comparison, a substring of the const passing by value reference of const standard string ampersand is more expensive, and the substring must point at some point must be copied to standard string that the reference parameter binds to. Okay, I think we'll leave it there. So left off at lesson 12.7, intro to params, to pointers rather. Okay, cool. Where are we in terms of this? So basically pointers and then the addresses, which we've done a bit before. So when you want a reference, or when you want to see the address, when you want to see the address, you do it before the, when you want to use the address, you do it before the variable, but when you want to create a reference, you do it with the reference type, or the return type rather. Okay, so introduction to pointers we'll do next lesson. So what are we on now? We're on day 27. So what did we do today? Let me close that. I'll close this as well. So today we did L value reference to const, and how it can be used. Initializing L value with a modifier L value. Initializing an L value to a const with an R value. Const references bound to a temporary object extend the lifetime of a temporary object. Because remember, we can use global and static local variables with const and const expression. No, sorry, that's wrong. Not const. Not const, but with const expression. We can use it with static with objects with static duration, aka global and static locals, but not non-static local variables. Okay. Pass by L value reference we did as well. We then also did pass by reference allows us to change the value of the argument because it's bound to. Yeah, and you can see via being bound, and you can see here the address is the same, or we use the address we used ampersand value to show it. And then pass by const L value reference. Passing arguments of a different type to a const L value parameter. Remember, that creates a temporary object. mixing pass by value and pass by reference, because remember you can have the same or different ones. You can have a value, you can have a reference, and you can have a value, you can have a pass by reference, or you can have a const pass by reference. When to use it. And then to prefer static string view over const reference string view. Okay, cool. Tutto bene. And today's date is the 27th. Okay, cool. That's that. Close that. And we left off at pointers. Cool. So, no. Yeah, so hopefully you enjoyed it as you're enjoying C++ if you're following along. Yeah. And if you saw anything I did that I shouldn't have done, let me know. If you've learnt different things, let me know. But yeah, and if you could leave a like, comment, subscribe, all that good stuff. And I'll see you in the next one. Bye.